Good morning, everyone. It's a pleasure to be here on behalf of Chrysos. Just also to acknowledge Andrew Weatherson is here, also from my team here in Perth. So thank you to Datamine for the opportunity to present here this morning, and hopefully this will be of some interest to all of you. So as you can see here, I'm going to be sharing the story of our connection with the Ravenswood Gold Mine up in northern Queensland. And I'll also try and weave in a few broader observations and narratives that we're picking up in the industry and with a number of site visits that we've been making. Okay. All right. I guess firstly, this presentation was actually the subject of a paper and also a presentation that we did at World Gold early this year in Denver. Special thanks to the team at Ravenswood. They're a great team. Led by Brett Fletcher, who is their CEO, Jason McNamara, their geology manager, and Daniel Candiero, who's their laboratory manager. I've had the good fortune of being up there on a number of visits. We've actually taken some potential clients up there, and every visit has been very enjoyable and very positive. So I'm going to start off by posing a question, which it really appears to me to be a really fundamental one. And this is really, especially in the gold industry, what could you do with much faster assay data? Before joining Chrysos, I spent many years in the realm of online analysis systems, especially in base metal flotation plants, where I was used to thinking of data turnaround of the order of minutes. And when I started with Chrysos and actually started talking to geologists, because until that time I don't think I'd ever spoken to a geologist professionally, it was all metallurgists, I got the idea that we were now talking days and weeks and sometimes months. And that continues to, I guess, occupy some of my thoughts in this whole area. So we'll come back to that, and in particular around the Ravenswood experience. Okay, so what is PhotonAssay? For those of you that may not know of us, Chrysos was essentially a technology spin-out company from research that had been undertaken by the CSIRO, Australia's National Research Organisation, for those that may not know. That research occupied around 15 years of effort, so this is hardly something that's just fallen off the back of a truck. So Chrysos opened its doors at the beginning of 2017. We're based or headquartered in Adelaide, and we opened our doors here in Perth during the course of 2019, at which time I actually transitioned from Adelaide to start living here in Western Australia. Okay, so what is PhotonAssay? Just as a little nod to the physics of all of this, the underlying technique was called gamma activation analysis. We coined it PhotonAssay as distinct from fire assay and other alternative and existing techniques. It's a faster, safer, and more accurate gold analysis, we feel, that we've now been offering the gold or the precious metals market now since Chrysos started. How does it work in brief? Because we'll come back to this. It's a nuclear physics technique. It all starts with the bombardment of the sample to be measured by high energy X-rays. It then causes an excitation of the nuclei of the atoms of interest. That then sets off the emission of characteristic gamma radiation, which we then capture, and then from that it then passes through our calibration algorithm to eventually produce an output of gold assays. We also measure silver and copper. Since we put this deck together, we did have 34 units deployed at that time. We're now up to 40 around the world, primarily here in Australasia, both East and West Africa, and North America are the main markets where we're present internationally. And as you can see at the bottom there, our customers tend to fall in two broad camps: the commercial laboratory companies, as you can see there, the likes of SGS, ALS, Intertek, MSA Labs, and others, and then the miners directly. Right, so let's just unpack a little bit how PhotonAssay actually works in practice. First of all, we have to get a sample together. Obviously, that's a whole story in and of itself, which I'll come back to a little bit as well. We typically measure a crushed product at -2 or -3 millimeters. It's normally dry, but it doesn't have to be dry. And we load that then into a PhotonAssay sample jar, as you can see there in the photo. And with that, it's then introduced into the system. we have a operator at the kiosk, as you'll see in a picture to come. It then goes into, the system is quite large. It has a footprint of 6 meters by 7 meters. It actually consists of 3 cabins, which when we deploy these systems, are shipped separately. We bring them together. So the middle cabin is where the excitation happens, where the irradiation of the sample jar by the high energy X-rays occurs. That comes out of a device called a LINAC, a linear accelerator. We use an energy of 8.5 mega electron volts for that process. In the case of gold, that then causes the gold nuclei to go into this excited state, which is called an isomeric state. It has a half-life of just under 8 seconds. And we do that for 15 seconds. We then transport the sample jar into the front portion of the system, where we then measure it or detect it with a top and a bottom detector. We do that for 15 seconds again, and then we repeat the process. And with that, we then are capturing 279 keV gamma rays off the gold nuclei, and that is, if you like, the characteristic signature that we're calibrating to. All that happens very quickly. So when the system is running normally, you can see there on average 70 samples per hour, upwards of 40,000 samples per month, or actually it can be higher if everything's going hummingly well. So you can see there it's very fast and it's very automated, and that is some of the ways in which it is a somewhat disruptive technology into the gold mining industry. Okay, so for those of you that may not know, Ravenswood is located up in FNQ, far north Queensland. It's around about 130 kilometres to the south of Townsville, a relatively easy drive out of Townsville. It processes around about 5 million tonnes per annum of ore, producing last year 175,000 ounces of gold. It's got quartz sulfide gold veins, free milling. And when we first went up there to discuss PhotonAssay, they were using an on-site PAL laboratory with Aqua Regia, and also, where necessary, off-site fire assay. They've been using PhotonAssay successfully since 2022. Okay, what were some of the challenges that Ravenswood faced when we first went up there to discuss? At that point in time, they were considering what they were going to do with their on-site laboratory and also the off-site fire assay that we're doing at the time. They were suffering a lot of backlog of samples that was certainly slowing their decision-making. Their PAL laboratory had limited throughput, which was causing delays. That led to the overflow of material having to be sent to an off-site laboratory in Townsville. And the mining team and the geology team had a lot of juggling to do in terms of trying to work with this system and actually make their operation work sufficiently well. As you can see, they had 3 different assay processes, which also had causes challenges in terms of QA/QC and consistency, and they had relatively poor mine-to-mill reconciliation. All right, so as we started to talk to them, this is quite common in what we do, they wanted to see how well PhotonAssay could compare against their existing processes. As I said, this is something quite common to most gold mining companies. So we had 2 phases of this. I won't go into great detail, but I will say that we spend a lot of time and have spent a lot of time doing this. Andrew here sitting at the table is enmeshed into this process. So we started off initially with a suite of tailing samples from the metallurgical plant. Oftentimes we're asked, can you measure gold down at, say, roughly 0.1 parts per million in terms of plant tails? So that invokes a whole conversation. So that's where we started with Ravenswood. And then subsequent to that, and then prior to taking a commercial decision, they also sent nearly 300 geology samples primarily. That study was done without our direct participation. Oftentimes we manage these studies on behalf of our mining clients. So I'll just talk you through a little bit of this as we go forward. So with the tailing samples, I mentioned before that we utilize 2 cycles of measurement. That's 2 cycles of irradiation and detection. We can increase that, and if we increase those cycles, we then increase, or rather we improve the precision of the analysis, and we also lower the detection limit. So we employed that facility when we did the 30 samples, the 30 tail samples, by using a 10 cycle service. Of course, that does slow throughput, but we did it to really emphasise to Ravenswood that we could meet their requirements in terms of those plant tailing samples. I guess, as you can see there on the last dot point, one of the characteristics of the technique is that it is much more of a bulk analysis technique compared to most other competing techniques. Not so much the leaching techniques, which do typically dissolve, say, a half a kilo or a kilo, but certainly against fire assay directly. So the typical mass is 500 grams, and I'll come back to that topic a bit later. All right, so there are some plots here, which I won't go into vast detail here. We often have produced a scatter plot with an R-squared value and a so-called Tucky plot here on the right-hand side. The Tucky plot is primarily for us to judge whether there is any bias between the two sets of results. That is normally the primary concern for most of our mining customers, to see are we equivalent, if you like, to fire assay. I could talk to you for the rest of the day about all of this because, you know, where does the truth lie? And where does if there is a bias, where does that source of bias lie? So these were the results from the tailing samples. These were considered to be accepted by Ravenswood at the time. And then we measured then a series of 280 odd geology samples, and then you can see the corresponding scatter plot there and also the corresponding Tucky plot. So we're looking to see if there's any statistically significant bias between the two populations of measurements, and if so, is that bias material or not? In a general sense, this phase is common to almost every gold mining company that we've spoken to, and it really is to say, in simple terms, is PhotonAssay equal to or hopefully superior to my existing assaying process? And if that can be proven adequately well that normally puts a tick in that box from a technical perspective, and then normally the conversation advances from there. Okay, I think this was one of my photos that I took on one of my site visits, and as you can see here, this is from the processing plant. And so at the very beginning, when I posed the question around total assay turnaround time, one thing in terms of Ravenswood and several of our other mining customer installations is that when you've got your laboratory on site and you can deploy PhotonAssay to that site, that is a key step in terms of reducing the sample turnaround time. You can see here the PhotonAssay building. Our system, as I said before, is quite large, a footprint of 6 meters by 7 meters, plus the access we need around it. So we do need a reasonable amount of space. And in this particular case, Ravenswood did have to build or construct a new building here, which they did fairly simply and easily in and around some other capital works that were going on at the time. And then right alongside it is the sample preparation facility. So a very quick transfer of material from the sample prep building into the PhotonAssay building. Okay, so finally you see a picture of one of these if you haven't before. It is a big white cube. It is almost 3 meters high. As I said before, it is deployed in terms of 3 separate cabins, which we then bring together through the installation commissioning phase. You can see there in the middle of those 2 conveyor belts a kiosk with a screen there. This is where the operator stands. So basically, to input a prepared jar, as you saw before, it takes 3 simple steps. We scan in the jar into the system. That normally then sets up a batch of samples for measurement. We then weigh the material, and then we also determine the fill volume with an optical sensor. With those 3 steps, which take around about 15 seconds, that jar is then placed onto the inlet conveyor, which is on the left-hand side of the picture there. And then the machine goes to work. So if you were to compare that to, say, fire assay, which has upwards of about 25 manual steps, very labour intensive, once it's on the inlet conveyor, then everything else is automated, and then the samples are ejected from the system after the analysis on that outlet conveyor. So you can see here the timeline. This project, and I'll just pause on this slide just a wee bit, this project proceeded quite quickly. As you've heard, we are not so much the young technology company that we were. So certainly when I first started, I think I was employee number 9, but still we're not deemed to be a legacy technology. I guess the visitors, and these have been from some of the largest gold mining companies, when they've visited Ravenswood, it's been a very surprising experience in the sense of the speed at which they took a decision to actually convert their existing assay process to PhotonAssay. At the time, we had a delivery of around about 8 to 9 months on these units. That has been reduced, And so you can see from completing the feasibility studies and then signing the contract, which didn't take all that much time after that, we had the unit arrive in mid-2022, and then the unit was then operational a couple of months after that and has been running successfully since then. Okay, so what has been the experience of PhotonAssay for Ravenswood in particular? And again, I might just bring in a few other threads for this portion of the discussion. So in brief, certainly improved drilling efficiency. As you heard before, they had some real problems in that sense. Enhanced data quality, a better handle on their metallurgical process control performance, definitely an improvement in safety and ESG within the lab, and pardon me, and then an extension of insourcing of their laboratory requirements to site. So let's have a look at those in a little bit more depth. Reducing the turnaround on their drill results, fundamental. Also which obviously goes hand in hand without the bottlenecks that they were suffering previously. And I guess this opens up the opportunity in these areas to really think about what you can do with a faster data flow. We heard previously a lot of discussion around data, which obviously Datamine specialise in. We are one of those ways of creating data, and just for interest's sake, we don't actually sell these as a capital equipment purchase. We lease these. So in essence, what any customer is buying from Chrysos is a stream of data, which then obviously part of the objective here is how can that be most effectively put to use. So in this particular case, it does open up the possibility, which Ravenswood have taken advantage of actually using that much faster data turnaround to actually do an optimization around their drilling programs and what that can mean for them in terms of grade control. And it also leads to a more efficient utilization of those drill rigs. Okay, enhanced data quality. The first box there around sampling errors. Again, this is a big topic. In my experience in mining over a long time now with analytical technology, sampling error is often overlooked. Obviously within the gold arena, the gold industry, it can be extremely challenging for heterogeneous gold deposits. We spend a lot of time, technically speaking, looking at this for each of our customers. I mentioned before the 500 grams of crushed material that we typically measure. That's 10 times the mass of a equivalent fire assay aliquot. So in essence, when we're looking at the optimum setup for PhotonAssay, we draw upon three levers to really optimize that the forward assaying process. One is sample mass, the second one is the particle size of the samples, and then the third one, where necessary, and I've touched upon it for tailings analysis, if necessary, is the number of cycles. So we have a way then to tailor the analysis to meet the objectives of that particular operation. The machine works continuously. It obviously needs some maintenance. Our target uptime is 95%. It runs automated QA/QC software, so at the end of each batch of assays, the machine automatically then analyzes a number of monitoring standards, which are CRNs, which are inserted in that particular batch. And if that passes, then the batch is immediately reported. It typically then gets into the laboratory LIMS system. If there is a fail, then that passes off to one of our physics operations teams, which are located around the world, and we provide 24/7 support. The method is non-destructive, which offers up a number of interesting possibilities. So as it comes off the outlet conveyor, the operator will then collect those samples. They can be then passed for post-PhotonAssay assaying where necessary. They can be archived for future reference if need be, or the material can be taken out of the jar and disposed of. The jars are also reusable. Okay, this is an interesting one, especially with my previous experience. When the gold processing plants that I've visited, what is typical is to collect shift composite samples, and then, what has been the reality is then wait any number of hours, if not a day or two, to get those assays back. And so that is very much a historical review on the plant performance at the time. So as you could see from the photos, the laboratory here is literally just across the road from the processing plant. So with some effort, one can get samples from the processing plant, get them into the laboratory and prepped very quickly. And then we have a so-called priority lane on the PhotonAssay machine, which then enables us to then analyze, say, priority samples, which could be metallurgical process control samples very quickly. So if you can then start to really reduce that period of time, and that's hence the very first question, then the total assay turnaround time, in this particular case with Ravenswood, they've been able to achieve a 4-hour turnaround, which is obviously a significant improvement from what they've had previously. Depending on the chain of events upstream of PhotonAssay, it would be possible to further reduce that. And then the whole sample measuring, I think in particular, that could be very interesting around metallurgical accounting samples, where you might have, say, 3 kilos of total sample, and rather than have to necessarily subsample that, we could easily split that to extinction and measure, say, 6 jars worth very quickly with PhotonAssay. Now, I think this is a very interesting one for the gold mining industry, whether it's an existing technique using fire assay process with lead, or whether in this particular case a PAL, pulverized and leach using cyanide, but typically gold analysis has been characterized by problematic reagents and substances which have been present in the laboratory space. As we all know, mining and mining companies worldwide prioritize safety. And so adopting PhotonAssay to site leads to a distinct improvement in the occupational health and safety. It completely eliminates the need for any toxic reagents or hazardous substances like lead for disposal. As you've seen at Ravenswood, they just measure a crushed material, so that eliminates a pulverizing step, which obviously potentially takes dust out of the working environment, even notwithstanding dust extraction systems, of course, saves time and saves costs as well. Now, this is an interesting one for me. Ravenswood, in this particular case, as you've heard, were running their own PAL laboratory, on-site laboratory, and offshoring fire assay. And so they maintain that capability. To this point in time, they've been a somewhat unique customer in that sense, because they continue to run their own laboratory, now using PhotonAssay. They've certainly been able to enjoy a number of operational enhancements, improvements in efficiency, etc. And by keeping the lab in-house, it's entirely under their control. And so they can flex the laboratory to meet the demands of samples coming from across the mining value chain. And as we've heard before, I mean, that's where all of this material originates from. And so as a function of the desired turnaround time and how that data can be best put to use, they're in complete control of that. Now, they average around about 20,000 samples per month, which, if you remember from an earlier slide, that's around about half of the volumetric or the sample throughput of a PhotonAssay machine. So even in a case where perhaps we need the machine for a day for some preventative maintenance, it means we can quickly catch up on any accumulated samples. And I think this, from a broader perspective, is an interesting notion for gold miners in particular to consider, is the fact that the automation of what has been a very complicated technique up until now allows the possibility to bring the laboratory back to site and potentially back under site control. Okay, so here's a quote from Brett, where he said at the time, because we did make some interesting videos which you can see on the internet or from our website, not only did it meet all of the needs we had, but it's actually going to be a cheaper solution for us, in the order of 5 to 10% cheaper. I would like to think from the visits that I've made up there that Ravenswood are very satisfied with the technology decision that they took at the time. As I discussed, it was one that they didn't belabor and moved, in fact, a lot faster than other parts of the gold industry. And I guess that just goes to show that if you are a technology company, you do actually need customers like this that are prepared to move fast and not necessarily dot every I imaginable and cross every T imaginable. All right, and that takes us back to the first question, which again I think is really central, because given that we're producing a data stream that can happen very fast, whether it's communicated into a LIMS platform, we are starting to think a little bit more at the moment around the possibilities for PhotonAssay to connect straight into a geology database, but that's a whole other topic for further thought and perhaps discussion at another time. But yeah, I think this is the collapsing of this is where PhotonAssay, I think, is proven to be quite disruptive. But it also means changing processes. The existing processes, from my observation, have often been around waiting for a long time to get assay data. And now that there's the distinct opportunity to wait a whole lot less time and then hopefully look for optimization strategies across the mining value chain. All right, so just a quick map there, as I mentioned before, where we're predominantly present at the moment. So look, I hope with that, that's all given you a little bit of an idea of PhotonAssay and what we're doing at Chrysos and what has been a very successful journey to date with Ravenswood Gold Mine. Thank you.